Hello everyone. So this time we will be discussing about vectors. So first, we have to know what vector is. So when we say vectors, we're only dealing with the direction and length. So dalawa lang yan. Direction, length, or magnitude. But before that, let us first review the x and y coordinates. So in x and y coordinates, we are dividing that by tips. So for example, we have an interval of 1, and if we're going to place a dot or point, we can easily locate that by drawing horizontal and vertical line. So for example, we have point P. We can easily locate that as 0.53 in the coordinate plane. So that is point P. For another example, we have point Q. We can also do the same to locate. So we have -4, 2 as the location of our point Q. When we say vector kasi, it has direction and length, but no position. It can be in origin, but sometimes, kahit hindi siya nasa origin, we can still call that as a vector. So, ang vector kasi, pwedeng pahabain or paiksiin. Pwede din siyang mag-change ng position. Just like that. So, in the coordinate plane, we can say a vector A is at 5, 3. 5, 3, meaning yung 5 is the x and 3 is the y. So, although it's not in the origin, we can still locate that. But, instead of saying vector A is that arrow, we can just say vector A is equal to 5, 3. So, yung 5, 3 dyan, pwedeng horizontal or pwede ring vertical. Okay. Basta we have to be aware of our x and y coordinates. So, we have here another example, vector B, -4 and 2. So, that is x and y. So, let us now move on to the scalar operations. When we say scalar operations, these are the operations that can be made in vector and scalar. For example, if we are going to multiply vector A with scalar x, or divide vector A with the scalar x. In doing that, we are going to assign the elements in a vector multiplied to the scalar x. Let's have an example using numbers. Let's say vector A is 2, 1, and we are going to multiply that with the scalar x, which is equal to 3. So we're going to put the elements of vector A and 3. So that is 2 times 3 and 1 times 3. And that is equal to 6, 3. So if we're going to graph the vector, we notice that its original length has been tripled. And if we're going to follow its tail from the origin up to its head, so that is at the point 6, 3. How about in division? So, pag division, we notice that the vector from its original length, yung kulay blue, if we are going to divide it by 3, we can see that it has been shrunk 3 times from its original length. How about if we are going to multiply it by its negative? So let's say we have vector A is equal to 2, 1, and multiplied by scalar x, which is equal to -1, then that is -2, -1. So we can see that the vector moves to its opposite direction. So that is scalar operations. Now let us move on to vector operations. So it is possible to add vectors. let's say we have vector A and B. So if we are going to do that, just like in scalar operations, we are going to put the elements of vectors in the matrix and then add. So for example, we have here vector A, that is 5, 1, and vector B, that is 2, 3. If we're going to add that, that is 5 plus 2, 1 plus 3. So that is 7, 4. So the sum of vector A and B is 7, 4. So in a graph, so we have vector A and B, that is 5, 1, and 2, 3. So in our coordinate plane, we have vectors A and B, 5, 1, and 2, 3. And if we're going to add that, or if we're going to add vector B to vector A, we're going to put the tail of the vector B into the head of vector A. So you can see in the illustration, nasa taas na nung head ng vector A yung vector B. And then, from the tail of the original vector or vector A up to the head of the addend, which is vector V, the sum is 7, 4. So that makes sense because if you're going to count from the origin where the tail of vector A has been initialized, so that is 7 units to the right and 4 units up. So that is 7, 4. That is the graph of the sum of vector A and B. So same with subtraction. If we're going to subtract that, so 5, 1 minus 2, 3 is 3, negative 2. So the location now of the difference of the vector from its head, that is 3 units to the right, and the tail is 3 units from its head. So that is 3, 2. So let us have an example. Here we're going to prove if is a set of all vectors in R2 of the form XX with the usual definition of vector addition and scalar multiplication of vector space. So in your module, you have the properties of a vector space. So we're going to use that to prove that all vectors in R2 are vector space. So we will let vector U be XX, vector V be YY, and vector W be ZZ. So we are going to prove these are vector space using the properties. So we have the first one, we have the vector U plus vector V is an element of a vector space. So we have vector U, that is XX, plus vector V, that is YY, and that is also same as X plus Y, X plus Y, and this is an element of vector space. So that is closure under addition. Next, we have another property, which is vector U plus vector V is equal to V plus vector U is an element of vector space. So we're going to prove that the two vectors can be commutative. So we know that vector U is XX and vector V is YY, and the sum of that is X plus Y, X plus Y, which can also be written as Y plus X, Y plus X, which is also equal to vector V plus vector U. So that means it is commutative. Next, we have associativity. So we're going to prove that vectors can be also associative. So we have vector U plus vector V plus vector w is also same as vector u plus vector v plus vector w. We know that the sum of vector u and vector v is x plus y, plus we have vector w, that is z, which can also be written as x plus y plus z, is x plus y plus z, x plus y plus z, which is also equal to the x plus y plus z, x plus y plus z. So this property was satisfied. Next, we have the zero vector. So we will prove that vector u when added to zero vector is also same as vector u. So we know that vector u is x plus, we're going to add 0, 0. So that means that is still x, which is also vector u. Next property, if we're going to add a vector with its negative inverse, then the sum is 0. So let's say vector u, that is x plus negative x, so that is 0, 0. Next, we have property number 6.